Okay, guys, on number 70, where is the midline? Up 3. Do you notice that I didn't put any graphing where you have to graph on a specific window? Yeah, you're welcome. I accept thanks in $5 bills. I know. You can turn me in. Okay, so plus 3 is my midline because that plus 3 on the outside. What is the amplitude? Is it negative 5 halves or just 5 halves? Just 5 halves. 5 divided by 2 is 2.5. So I'm going to go up 2.5. I have that light on. Is that creating too much of a issue? Fine. Okay, fine. It still creates a shadow. Who cares? Okay, so 2.5. So up 2.5 and down 2.5. Yeah? Okay, what does the negative do? Good. Flips the wave over. And what is the period? How do I find period? 2 pi divided by what? 1/4, because b is 1/4, right? Good. Dividing by 1/4 is the same thing as multiplying by 4, so the period is 8 pi. I said graph how many periods? 2. So to the right, I've got 4 spaces. Should I make that 8 pi? Which makes that negative 8 pi. And I said I want you to label the x-coordinates of the 5 main points. So 0, 8 pi, so half of that is 4 pi, half of that is 2 pi, which means we're going on a scale of 2 pi, so 6 pi, yeah? The end of the wave is, one period is 8 pi, so I just cut that in half, and then I cut that in half, and then count it by 2's. So negative 2 pi, negative 4 pi, negative 6 pi, yeah? It's pretty easy if it's just one wave to go ahead and sketch where it's supposed to be. It's a negative sine wave, right? What is a negative sine wave? Where does it start? Amplitude or midline? Midline. It goes down because of the negative, right? Make sure that you go all the way down to your dotted line. Go back, put a dot, go up to your max, and then go to the midline. And then just keep the wave going on the other side. Okay? And then we sketch. What do I not like to see? A lot of V's without any kind of curve. Make sure that I can tell it's a max and a min. This is not absolute value functions. Yeah?
Yeah.
You guys are all so funny. Okay. Especially you, Dennis. Okay. No, I don't like Dennis. I was just saying that. I'm just kidding, Dennis. I love you. Okay. So there we go, yeah?
Sure.
All right. On the next one, what is the midline? What's the vertical shift? A half. Is that called annoying?
Yes.
A little bit, but I made it that way, so whatever. I'm sorry, you just mispronounced your own name, Ashton. Okay, so 1/2. Okay, so 1/2. Isaac, at every moment I am talking to you, okay? All right. So the amplitude is 1/2. Yeah, no. And what is the, sorry, I just said the amplitude. The midline is 1/2. What's the amplitude?
A tree.
So I'm going to go up 3 from that. So 1, 2, 3, that puts me at 3.5, right?
Yes.
Okay. Why did I do that as a dotted line? My bad. Y'all weren't going to say anything. You were just going to let me be wrong. Aubrey, that's wrong. 1, 2, 3. Okay. All right. Okay. So, what's the period? 2 pi divided by what? 2 pi divided by 4, and Caleb is saying that that is pi over 2, 1/2 pi, right? So where do I put 1/2 pi? Halfway through? Okay, so that is 0. What's half of a half? What's half of a fourth?
An eighth.
What's an eighth times 3?
Oh, that's, you need 3 eighths.
1 eighths, 2 eighths, 3 eighths, 4 eighths, 5 eighths. 6 eighths is 3/4. So 7 eighths. 8 eighths is pi. I mean, if you think about it in fourths, 1/4, 2/4, 3/4, 4/4, right? But I'm just, so it's a little bit easy to break it up. But anyway, because I'm not good at this. Okay, so it's a cosine wave with a period of 1/2, right? 1/2 pi. So I know it should start at the top and end at the top, and we're going to do 2 of those. Halfway through, I should be at the minimum, midline, 1/4, and 3/4 of the way. Just gonna show you. That's not very symmetrical. Okay. Alright, so now we need to write the equations, right? Okay, so when you're trying to do the writing, this is a cosine wave, right? Does it have an amplitude?
Sure.
I mean, it does. The amplitude is 1, right? If it's not written, it's 1. Is there a vertical shift? So we go -3. What goes inside there other than x? Because you definitely have to have an x in there. If you don't, it's not a function. Well, b, right? So I need to set the formula for period 2 pi over b equal to, good, the actual period 8 pi over 3. Okay. Now, what are we going to do? I mean, what do we do every single time? You multiply by b, and then you multiply by 3 over 8 pi, the reciprocal. Pi's cancel out. Do 2 and 8 simplify? Yep. So 2 and 8 simplify to 1 and 4, so it's 3/4. And there you go. I thought it'd help if I got really close. Okay. So, Wade, you're wrong. Y equals. What is your amplitude?
-4.
Okay, your amplitude is just 4, but why did you say negative?
Because it's reflected on the x-axis.
Reflected over the x means there's a negative. It's a sine wave. Is there a vertical shift?
Yes. Up,
So +9. What has to go in there every time?
something in x.
Okay, could it be theta?
Sure.
As long as you have a variable in there, right? So I need to find b. What do I do?
Say equal
Good. You can write it as 14 pi over 1. I'm going to multiply by b. And then what? Or just divide by 14 pi, right? So pi's cancel out, 2 and 14, 1 over 7. And there you go. Sure, you can just put theta over 7. Okay. You need to write the equation. Don't just tell me it's a sine wave, it's a cosine wave. I need to actually see the equation. What do I always suggest that you plot first? The point where it hits the y-axis.
True.
If you plot the point where it hits the y-axis first, you know automatically whether or not it's a sine or a cosine wave. Is it a sine or a cosine?
Sine.
It starts on the y-axis in the middle, so it's a sine wave. Now, that being said, it's a sine wave to you because you haven't learned about phase shift. When you go to pre-cal, that's not a tried and true always. It's not always going to be the case, okay? This looks like a sine wave, but it could be a cosine wave shifted to the left or to the right, okay? So when you learn about phase shifts, it'll just add more to it. But right now, for what you know, where it starts, you'll learn, okay? All right, so guys, if that's a sine wave and that's the middle, then isn't that telling me my vertical shift?
Sure, up forward.
It's at 4, but it is, the amplitude is 5? Because that's 9 and that's -1? Yeah. Yeah, someone just said that. So that distance is 10 and half of that is 5, so my amplitude is 5. Is it a positive or a negative? It starts at the y-axis and goes up, at the midline goes up. And how do I figure out the period of the wave? Well, first I gotta find the period, right? In a sine wave, how much is it, do we see right here? How much of a sine wave? We see half, so if half is half a pi, then what's the whole period? The period is pi. So 2 pi over b equals pi? 2 pi divided by what gives you pi? 2. 2. So multiply by b, divide by pi. B equals 2. Okay, on 75. Guys, what did I say you should plot first?
Where it hits the y-axis.
Alright, where does it hit the y-axis?
That's a cosine wave.
At -2, and it hits it at the bottom of the wave, so you're right, it is a cosine wave. Is it a positive or a negative cosine wave? It is a negative cosine wave, because it starts at the bottom. What's the top? What's that? 4? So what's the distance?
6, so it's a 3.
Woo! I'm thinking 3, so I wrote it. 6 divided by 2 is 3, so that means that's my amplitude, yeah?
Yeah, good job.
Thanks. Okay, so that means right there is my midline of +1. Okay, my midline. Okay, all right. I never will. Okay, so I'm sorry. Did someone just talk? So there's my negative cosine wave. Okay, so what is your period?
16.
I just circled it, so I hope that's it. Caleb, you have trouble laughing. You don't need to work on that. 2 pi equals 16 pi. 2 pi over b equals 16 pi. So what do? Multiply by b?
And then you divide by 16.
Divide by 16 pi?
It's 1/8.
Okay, y'all are crazy. Okay, we good?
Maybe.
Alright, let's go to number 76. Sure.
I will love life.
Okay. Pretend you are getting on a Ferris wheel at the very bottom, and the Ferris wheel has a radius of 25 feet, and the bottom of the wheel is 7 feet off the ground. Go ahead and draw your Ferris wheel.
Isn't that a triangle?
Here's my perfect Ferris wheel, and don't y'all say anything about it.
See, you have to draw the face. Mr. Hosky, why does your first one staple
My Ferris wheel has been stapled to the ground. Okay. The Ferris wheel is how far off the ground?
Oh, 7 foot.
Okay, so that right there is 7 feet. Please stop talking. What else do you know?
The thing has a 25-foot radius.
So this right here is
So it's 50 foot across.
diameter is 50 foot.
Yes.
Okay, so pretend you are getting on a Ferris wheel at the very bottom. Draw an X and a Y, but draw your X at the very bottom.
Wait, from what was 7 foot too?
No, just draw an X and a Y like I did.
Oh, okay.
Okay. If you get on the Ferris wheel at the very bottom of the wave, how high in the air are you? 7 feet. So draw that.
You get a vertical shift of
Okay. Now, guys, how many points do we usually draw on a sine and cosine wave? Okay, 5. So that means starting, a quarter of the way through, halfway through, 3/4 of the way through, and back to the beginning, right? So this is going to be 0.1 and this is going to be 0.2. Now, how far off the ground am I now?
let's say 45 plus 7 feet.
32?
2 feet. Yeah.
Okay, so let's let this be 32.
That's probably dressed.
And I'm right there. Now, where am I at the halfway mark?
57 foot.
Yeah, I'm 57 feet in the air, right?
True.
Okay. What about 3/4 of the way?
You're back at 32 feet.
Back at 32 feet?
And then back at 7 feet.
And then when I end up back at the bottom of the Ferris wheel, we are back at 7 feet, right? Guys, if you were to connect this, what would it be?
Sine wave.
I'm going to pretend by sine you said negative cosine.
What do you mean? It could be one. How dare you say so?
Uh-huh. Y equals what?
Negative cosine wave.
Yeah, and some people are paying attention to me. Others maybe not so much. This is my midline, and so my amplitude is
25.
25. Where's my midline?
At 32.
32. You know what we didn't graph? What's the only thing that we haven't talked about yet? The period. It takes how long to complete one wave? So if that's 60, what's half of that?
30.
And half of that? I'm going to go 15, which makes this 45. I know. It's fine. Okay, so the period, and we're going to keep this in radian mode, so we set still 2 pi over b equal to 60. And then what do I do?
It's 2 over 60 or
Almost. So you multiply by b, and you get 2 pi equals 60b, right?
yeah.
You need to divide by 60. Does the pi's cancel out? There's only one. So I agree that it's 1/30th, but it's actually pi over 30. We good? Okay. 77. Okay. So we need to go through, guys, everyone needs to have a calculator handy. And we're going to go ahead and do all of this.
That's a lot of numbers.
Okay, now I'm telling you that I want you to do this by hand, so guys, what do? What's the first thing you do?
Add it all the numbers.
Okay, so first we need to find the mean. Add them all up and average them. How many points are there? Have you counted? I'm pretty sure there's 19. So 0.5 plus 3 plus 2 plus 8 plus 4.5 plus 12 plus 1 plus 1.5 plus 6 plus 2.5 plus 4 plus 3 plus 1.5 plus 1.75 plus 5 plus 7 plus 3.25 plus 10 plus 4.5.
Should be like 80.
I know, but you could be following your own. Yeah. Divided by, oh yeah, I need to go ahead and find that out. It is 81. Divided by what? I think it's 19. So we're going to go ahead and let the mean be 4.26. Please stop talking. 4.26 is the mean. What do I do now? Huh? Okay. Maybe? No. We gotta find the differences between the mean and the data points. Yeah. Oh, okay. Sorry. So, guys, what's an easy way to do this?
You have to put x, and then you subtract from
Okay. X minus 4.26.
Yes.
Okay, go to second what?
Table. Oh, wait, you have to do
Table set. Change that to ask instead of auto. So go to second table set, ask on independent, and then go to your table. Delete anything that's in there. And start entering them in. So what's the first one? 0.5?
yes.
So negative 3.76. Negative 1.26. Negative 2.26. 3.74. I'm going to cross them out as I go. 4.5. So 0.24. 12 is 7.74. Negative 3.26. Negative 2.76. 1.74. Negative 1.76. 4 is negative 0.26. 3 is negative 1.26. 1.5, I feel like I've already done that. Negative 2.76. 1.75. Negative 2.51. 5 is 0.74. 7 is 2.74. 3.25 is negative 1.01. 10 is 5.74. And 4.5 is 0.24. Okay, so first we find the mean. Second we find the differences. Now what do I do?
Square the middle.
Okay, square 'em. So now what do I do?
Y equals x squared.
I go to y equals, change that to x squared, and then go to second table and enter in my now y values, right? Or my y values of the previous as my x values now, right? Okay. So, negative. Actually, I never type in the negatives. Why not?
It doesn't matter, it's gonna be positive.
Exactly. It's just going to become positive. So since I only did 2 decimals on that, I'm only going to do 2 decimals on this. So 14.14. 1.59. 5.11. 13.99. Thank you, Kayla. 0.06. Are y'all not doing it as well? Oh, why don't I just do all the work for you? In fact, don't even worry about it when you're taking the test. Just assume that I'll fill it out for you. Except for I won't. So y'all could be doing it too. 10.63. 2.76. If I'm the only one doing it, then who's checking me? Mm-hmm. So 1.26. Please, guys, I don't have to say please be quiet in any class but this one when I'm videoing, so I'd appreciate it. If you'd stop 7. Why did I do that again? 6.30. 0.55. 7.51. 1.02. 32.95 and 0.06. Huh? Oh, thank you. I'm a professional. Okay, what do we do? Now, find the mean of those, right? Okay, so, still 19 terms, right? Please watch what I'm entering and make sure I don't miss something. Whoop. Thank you. So I got 176 thank you, divided by 19. So that is 9.307895. And then last step, square root. .051, or this is just 3.05, yeah? So I got my square root is 3.05. What is that? That is my standard deviation. Now what we are doing is we are assuming that this is the whole population of the animal shelter, right? If it was only 19 of the 47 animals, then what would you have to do? Okay. Ashton. Okay. Okay, it says confirm using the calculator. What should I do? Okay, you guys are so smart. So where stat? Edit, because I haven't put them in yet. Would y'all read them? Would someone read them off to me?
Yes, ma'am, I got you, Miss Vonsky. 0.5, 3, 2, 8, 4.5, 12, 1, 1.5, 6, 2.5, 4, 3, 1.5, 1.75, 5, 7, 3.25, 10, 4.5.
We good? Stat, and then what?
Calculate 180.
He was helpful. Okay. So, did we get our mean right, 4.26? And our standard deviation, 3.05? Perfect. Like me. My bad, sorry. Okay. I'm not perfect, guys. I'm just close. Okay. Hey, so what am I wanting on this part? Okay, so what goes here? 4.26. What do I do next? Okay, I need someone doing that. 4.26 plus 3.05, 7.31. That's your mean, honey. That's your average. 10.36 is the next one. And 13.41. Okay. What about one to the left? 1.21. And what's the next one? Negative 1.84. Okay. Where can we kind of stop? It's a 1. Are you talking about that right there? That's an 8. Hey guys, can animals be negative years old? Okay. I shouldn't have asked that question to this class. Okay. I'm going to let that be 0. Yeah? Okay. So my curve should do something like this if it was a normal curve. But do we know if it's exactly normal? We actually don't. Could we kind of do a histogram if we wanted to? We want to because this is so much fun. 1, 2, 3. Anna Bloodworth likes this the most of everybody. Just want to put that in the video so everyone knows. Okay. You're welcome. Hey, guys, how many animals fall between 0 and 1.21? Let's see. 1, 2, just 2? How many fall between 1.21 and 4.26? Okay, that's wrong. So between 1.21 and 4.26. So 1, 2, 3, good. 4, 5, 6, 7, 8, 9, 10. 9? Huh? No. I'm saying this is x equals 0. 0 years of age. Right here. Yeah. The y-axis is going up by 1s. Yeah, guys, I only got 9. Okay. So that's 2, 3, 4, 5, 6, 7, 8, 9. There are 9 animals whose ages are between 1.21 and 4.26. What about 4.26 and 7.31? I'm going to write that in there. 9, 2, okay. 4.26 and 7.31. So 1, 2, 3. Just 3? So we're looking at 4.5, 6, 7. Is that it? Oh, and 5. Numbers between 4.26 and 7.31. So 4.5, 6, 5, and 7. So 4. Oh, 4.5 down the end. 5. Geez, I'm not good at this. 3, 4, 5. Perfect. Okay, 7.31 and 10.36. So I see 8. And 10. Is it just 8 and 10? So 2. What about 10.36 and 13.41? Just 1? The animal that's 12? Good. Yes, I am. Does that add up to 19? Because if it doesn't, then we're wrong. I'm thinking, yeah. That means we're perfect. Good job. Yes. I'm not gonna say anything. Okay. Okay. Hey, what percent of the animals fall within 1 standard deviation? Well, 1 standard deviation.
I can't see the deviations.
1 standard deviation is 1 to the right and 1 to the left. Please let me not have to talk over you. 1 to the left and 1 to the right of the mean, so that is 14 out of the total what? What's 14 divided by 19? 73.6%? Was I wrong on mine? My picture up there? Does someone have the picture of it real quick? Look at it real quick, because I think I might have been wrong. Okay, what about 2? 2 standard deviations.
18.
Yep. Yeah, I can't count on my picture. Hey guys, I'm wrong on my picture, okay? 18 out of 19, what's 18 out of 19? Okay. And then 3 standard deviations is 100%. Yeah, I apologize. I don't know what I was doing. Yeah, I did it after 6 hours of working on this. Okay. Hey, is that pretty close to the normal curve? 68.26, 95, and 99.7. I mean for only 19 points is pretty good, right? Would you say that is definitely normally distributed? I mean, yeah, because we cut it off right here, but I mean, technically it goes all the way over here, right? There's just nothing over there. I mean, it looks a little skewed left, but whatever. Okay, so this last problem, are we going to have time to do it all? Probably not, but we can start it. And then when y'all leave, I'm just going to keep the video going, so I will finish it up, okay? And then I'll post it. The first 4 videos are already posted, so if you want to look at anything. And I know your computers are going away, but you can still access the YouTube. Okay. Let us plot the points, please. Please stop talking. Everyone should be plotting points right now. So this kind of looks, I mean, if you look at the data. Whoa, did I get off? No. Okay, good, thanks. 8.37 and 11.21. Okay, guys, if you had to pick a function to fit this, what would you pick? Okay, we're not talking trig. I'm thinking a parabola type shape, right? Real life is messy though, so is it perfectly parabolic? No, but it's more parabolic than linear, right? So the first thing I do want you to do though is to graph a scatter plot and then calculate linear regression. So in stat edit, what do I enter into list 1? Right. I kind of forgot to do that the first time, so 3.66, 5 point. Okay, guys, be very careful on entering in data into the calculator, because a lot of times, depending on the calculator I'm using, if I try to press double like 11, a lot of times it doesn't press, or if I try to press enter, it depends on the calculator, how old it is, what's been dropped on it, whatever. So be careful about that. You might, I mean, guys, if this is a test, and this is what I did when I worked the problem, I went through and I made sure that all my data points are correct, and I would suggest that you do the same thing before you find that you have to redo the whole thing. So I want to find the linear regression. What do I do? Stat, calc, linreg for. Okay, store alpha trace y1. I don't see R. What should I do? Mode. Stat diagnostics on. Second quit. Second entry. Okay. So I get y equals what? Okay. And then correlation coefficient? Is that a really good one? It's not that great. And if I looked at the graph, I'm going to go to window and make sure, actually just kidding, I'm going to go second stat plot. I'm going to make sure my plot is on, make sure you're seeing the data, not the histogram. L1, L2, I'm going to go to my window. What's my window on my graph on here?
1 to 0 and 0 to 12.
0 to 12 on both? So if I press graph, then I see my data and my line, right?
Yes, ma'am.
Okay. I'm going to go ahead and sketch that line, just so we have a clear idea. I'm going to go to the table and look at 12. I don't know why I scrolled all the way down to do that, but 5.95, so it's close to here. So if I were to connect these two, then I could see basically what the linear regression looked like on my test. So here's what we got. Yes. There's my linear regression. Doesn't seem to fit the data well. And guys, what do you think the residuals are going to do?
They're going to go on this.
Huh? They're going to be somewhat pattern-like, because first they're above, then they're below, and then they're above, right? So I'll keep doing that. I'll post it on the video, and just remember to change the numbers on that last one we did. Okay, to sketch a graph of the residuals, first off you need to find the residual values. So we're going to go to Stat, Edit.
Do you happen to have a pen that I could take?
And then you press enter when you go over to L3. So you go over to L3, go up, press enter, and then go second, stat, and go to number 7. Press enter, and there are your residual values. Hey, can someone turn off the smartboard for me? Okay. Bye. Okay, so we graph the residual values, and I'm probably going to tell my students that I'm going to want to see them. I don't know what Mr. Hines is going to do, but if you're in my class, beware that I'm going to ask you to write them down. I don't. Sorry. 3.8. I don't know why I'm doing 2 decimals. I'm not going to be able to see 2 decimals. I'm just going to start doing 1. Negative 1.1. Bye. Negative 3.9. Negative 0.3. 2.8. 5.3. And that's it. Bye. So this is at 1. Remember, because we started at data set 1. So at 1, we're at 2.14. So keep in mind that that's 3, so 2.14 is like right there. 3 point, basically 4. So there's 3, 3.5, so somewhere in there. 2.15. Negative 0.7. So there's negative 1 right there. So negative 0.7 is like right there. Negative 2.55. So there's negative 3, so negative 2.55. Negative 3.3. Negative 3.8. Negative 1.1. Negative 3.9. Yeah. Negative 0.3. There's negative 1, so negative 0.3 is right there. 2.8. And 5.3. Okay. If I were to look at these residuals and think about whether or not they were random versus non-random, remember that you want your residuals to be close to the x-axis, and you want them to be above and below all around it. And what it seems to me is that at first they're above, then they're below, and then they're above again, which is kind of pattern-like. So what I would say is the fact that my R is 0.425, my residuals are somewhat parabolic, and the data itself was somewhat parabolic with the linear regression kind of going through it. I would say that's enough to say that that linear is not the best fit for it. Okay? So, on 81, it says calculate the quadratic regression. So now what we're going to do is we're going to do the quadratic. So I'm going to go stat, calculate, quadreg, alpha trace, to store that in y equals, calculate, and I get this. So I'm going to write that down. I don't know why it's lagging so much. Sorry if the audio is off. Okay. For some weird reason. It's being weird. Okay. Oh, that was silly. So y equals 0.249x squared minus 2.832x plus 8.664. Okay? And then r squared is 0.824, which is a lot better than the r for the linear. So what I want to do now is I want to graph the residuals. I want to find the residuals and graph them. So I'm going to go stat, edit, go up to list 3, and I'm going to press enter and clear out what's in there. You don't have to clear it, you can just type over it. But you go second stat and do residuals again, because the residuals in there are the residuals for the last one. Press enter, and now they're different. So let me write those down. Negative 2.4, 1.3, 2.1, 0.7, negative 0.1, negative 0.4, negative 0.9, 1.3, negative 2.5, negative 0.4, 0.7, and 0.7. Okay, so this graph is kind of, it's got a large scale, or it's not large, but compared to all these numbers, it's going to be, they're all going to be kind of close together, which is okay. So, let's plot them. Well, actually, before I plot those, let's just look at the graph. If you look at the graph, the quadratic is actually a whole lot, it's better. It's a better fit for the data, which kind of makes sense, was kind of what we thought in the first place. It's not perfect, which is why you're going to have residuals, but they are below, above, below, above, below, below, above, above. So it's a little bit more random, yeah? Now, I could graph it up in there, and I did. What I did was I went to second table set. I did this on the pictures that I posted on auto, and I go second, just kidding, yeah. And your function in the y equals right now is your quadratic. So if you graph these points, 8.7, 6.1, 4, 2.4, 1.3, you can actually see the quadratic. And you can, no, it doesn't ask for that, so you don't have to do that, okay? So I'm going to graph these residuals. Negative 2.4, 1.3, so 1.3, 2.1, 0.7, negative 0.1, negative 0.4, negative 0.9, 1.3, negative 2.5, negative 0.4, negative 0.7 and 0.7. So there's one. Okay. Much more random than that was. That one had a little bit more shape to it, whereas this is all kind of clumped around the x-axis, which is definitely what you want, okay? That being said, based on the correlation coefficient, I should say correlation coefficients, the residual values in your mathematical reasoning, which model is going to provide an accurate representation of the data, be specific. So I just talked about that, but I'm going to leave that up to you to actually verbalize it. I do want to go ahead and say, yeah, no, that's good. Okay, that's it.